Welcome to our comprehensive guide on water flooding techniques. In this video, we'll dive deep into one of the most critical methods in oil recovery. Water flooding is a secondary oil recovery method used to increase the amount of crude oil extracted from an oil field. It involves injecting water into the oil reservoir to push the oil towards production wells. So what exactly is water flooding? Water flooding is primarily used to maintain reservoir pressure and sweep the oil towards the production wells. It's crucial when natural reservoir energy depletes and primary recovery methods are no longer efficient. This technique significantly boosts oil recovery, often increasing it by 10 to 30% beyond what primary methods can achieve. It's a cornerstone of modern petroleum engineering. The basic principle of water flooding is simple. Water, being more dense than oil, displaces the oil in the porous rock formations. When water is injected into the reservoir, it acts as a piston, pushing the oil ahead of it. The injected water fills the pore spaces previously occupied by oil, driving the oil towards the producing wells. This process is known as immiscible displacement. Key forces at play include viscous forces, which drive the flow, and capillary forces, which affect the movement of fluids within the small pores of the rock. Water flooding can be implemented using various patterns, each designed to optimize the sweep efficiency and maximize oil recovery in different reservoir geometries. In a peripheral flood, water is injected along the edges of the oil reservoir, gradually pushing the oil towards the center where the production wells are located. This method is effective for large, continuous reservoirs. Pattern floods, such as the 5-spot and inverted 5-spot, involve a specific arrangement of injection and production wells. The 5-spot pattern has one injection well surrounded by 4 production wells, while the inverted 5-spot has one production well surrounded by 4 injection wells. These are popular for more uniform reservoirs. A line drive pattern consists of rows of injection wells facing rows of production wells. This pattern is often used for elongated reservoirs or when there's a strong directional permeability in the reservoir rock. Designing an effective water flood requires careful consideration of several factors, including reservoir characteristics, fluid properties, and operational parameters. Injectivity refers to how easily water can be injected into the reservoir. Sweep efficiency measures how effectively the injected water contacts and displaces the oil. Water quality is also critical, as impurities can cause plugging or damage to the reservoir. Reservoir heterogeneity, meaning variations in rock properties like permeability and porosity within the reservoir, can significantly impact the success of a water flood. Understanding these variations is crucial for optimal well placement and injection strategies. Monitoring the performance of a water flood is essential to assess its effectiveness and make necessary adjustments. Several key metrics are used for this purpose. The water-oil ratio, or WOR, indicates the amount of water produced per unit of oil. A rising WOR can signal water breakthrough or inefficient sweep. The oil recovery factor measures the percentage of original oil in place that has been recovered. Breakthrough time is the time it takes for injected water to first appear at the production wells. Early breakthrough can indicate channeling or poor sweep efficiency. Despite its effectiveness, water flooding presents several challenges that need to be addressed for optimal performance. Premature water breakthrough can lead to high water production and reduced oil recovery. Scaling, the deposition of mineral precipitates, and corrosion of equipment are common issues that require careful management through water treatment and material selection. Continuous monitoring and surveillance are vital for optimizing water flood performance. This involves analyzing production data, regularly checking well performance, and utilizing advanced reservoir simulation models to predict and adjust operations. Water flooding remains a cornerstone of enhanced oil recovery, offering significant benefits in maximizing hydrocarbon extraction. With ongoing advancements in technology and data analytics, the future of water flooding looks promising, ensuring more efficient and sustainable oil production for years to come.